The broadcast is now starting. All attendees are in listen-only mode.
Hey, good morning, everyone. Welcome to the Enology webinar series. My name is Dr. Andrea Botezatu. I am with Texas A&M University, Texas AgriLife Extension Services. Today's webinar will cover managing microbial populations, and today's presenter is Mr. Luke Holcombe of ScottLabs. Luke is a recurring presence in our webinar series, so I would like to start by saying thank you to him for supporting this program. Just a little bit of housekeeping before we proceed. If you have any questions during the presentation, please type them in the question box on your screen there. The presentation will take about 1 hour, and we'll have a little bit of time at the end for more questions and answers. And so without further ado, let's begin. Luke, the floor is yours.
All right, thank you. Thank you to Texas A&M and everyone tuning in to subject yourself to about an hour of me talking about microbial populations. So we'll get right into this. If you have any questions, go ahead and throw them in the chat. You can also email me or text me after the presentation, or call me, whatever you'd like, and answer some of the questions you may have or some clarification. But let's get right into it. So we're looking at managing microbial populations. You know, as winemakers, there are times when we want certain populations to be active and doing their work, such as during alcoholic fermentation and malolactic, if we choose to do that. But you know, in the rest of the wine's aging cycle and production, you know, we really want to control what we're doing. So we'll talk about some of the techniques to use, and some of the characteristics of the wines that we're making in Texas that present certain challenges. Also, some tips and tricks that you can use on problems that you may see in the cellar, and we'll kind of get into it from there. So get back to the screen here. So our main points, we're going to look at controlling these microbial populations via chemistry, i.e. controlling pH, SO2, dissolved oxygen, nutrition. This would primarily be nitrogenous sources as well as carbon sources. We'll also talk about physical population control via temperature control, fining agents, filtration, using other microorganisms to control the populations that we don't want to be active, and then also inhibitors and sterilants. Lastly, we'll talk cellar practices to achieve goals and tips and tricks to achieve those. On the upper right-hand side of the screen are a list of some of the major microorganisms that we deal with. If you looked at the overall scope of microorganisms available on the planet, we deal with a very, very narrow range of microorganisms. Thankfully, with the alcohol and the pH that we have, we don't have to worry about things like E. coli and listeria and some of those things that give people problems in other areas of food and beverage production. That being said, you know, there is a change in the winds as the FDA starts reviewing and inspecting wineries as food manufacturing facilities. They will point out areas where in other food plants, listeria and things like that can be an issue. And while they aren't necessarily for wineries, they're still going to want some sort of HACCP plan, critical control point analysis for that the winery needs to do in order to be in compliance. So that's a lovely thing that's coming down the pipeline that we need to be aware of. But for right now, we're going to focus on general winemaking. And that list there, you can see some of the major players: the Zygo, Saccharomyces, Brettanomyces, Candida, Acetobacter, Lacto, and Pediococcus are the ones that we're primarily going to look at today, just because they're seemingly the most prevalent. So pH control, you know, there's some people that believe that climate change has caused changes in chemistry and causing elevated alcohol levels. I think that is a component, as well as people looking for hang time and farming for sugar. Hitting some sugar level in order to determine ripeness has driven a lot of viticultural decisions, and it's painted us into a corner. Being so focused on sugar and not pH has led to some really high pHs, and in my opinion, just unbalanced wines. So, why would you correct pH? Well, this table that I have right there shows some of the differences when it comes to how a wine behaves according to pH, and pretty much in every regard, pH, if it's lower than 3.6, lower than 3.4, it really it oxidizes slower, color strength's better, the type of colors is better, protein stability is increased, and most importantly for this presentation, bacterial growth is slowed significantly at these lower pHs. One of the reasons why, we'll get into it, is the effectiveness of free SO2 and molecular SO2 at these lower pHs. I have a chart, and we'll discuss that at length. But it is, in my opinion, one of the most important parameters to control. And I'm not going to get into the ins and outs of pH and ions and conjugate acids and conjugate bases and all that sort of stuff. We're just going to talk about it kind of at a high level. So if you have pHs below 3.6, you get a lot of synergism that occurs. Your microbial inhibition is greatly increased. At cold stability, it's more favorable, less than 3.65 for what we're going for. The antimicrobial activity of SO2 is greatly increased, which we'll get into a little bit more. pHs above 3.6 allow for significantly more spoilage. Just to touch on it real quick, I'm probably saying something that everyone already knows, but pH is a logarithmic scale, so the difference between 3.1 and 4.1 is a factor of 10. So, some of the wines in Texas and in hotter climates can be, 3.8 to 4.2. I've even seen higher than that, and you're really not. The deck's stacked against you at those really high pHs, and so, generally speaking, it's advisable to do something about that. Also, kind of a strange phenomenon when it comes to pH meters. 3.6 is kind of the magic number, but pH meters have an accuracy of approximately 0.5 pH units, and this is also dependent on how old the probe is, how you treat the probe, what sort of cleaning regimen you have, how you buffer it, and then also just the quality of the pH meter. I would highly suggest investing in a high quality pH meter like a Thermo Orion. There are other, Mettler Toledo has some good ones. A pH stick, those little paper test strips are probably not recommended for what we're dealing with. So I would recommend a good pH meter. But because of the 0.5 pH unit accuracy, if you have a pH of 3.6 on your meter, it could be 3.55 to 3.65. So there is some variance there. So I typically recommend, acidulating to 3.55 or a little bit lower just to be in the safe zone. Acidulation pre-fermentation is really where you want to try to get your biggest shift. Very generally speaking, any sort of adjustment you do, especially something like acidulation, is better done at the juice stage compared to once it's already fermented out and is a somewhat finished wine. The juice just responds better. It's more forgiving. And the other thing that happens when you make pH adjustments at the juice stage is because you're moving the pH quite a bit, you're really being able to naturally, in a way, control some of the spoilage organisms. So you're subjecting them to a pretty significant amount of stress, which is good. ideally in Texas, with a lot of the grapes being grown in the high plains and trucked across the state in the middle of summer when it's really hot. If you have a Tempranillo near 4 and it's 100 degrees outside, spoilage can really occur very, very quickly, especially if you have compromised fruit in any way. If there's some rot or, insect or bird damage, the growth of spoilage organisms and the resulting metabolites, things like VA and mousy taint, can really occur very, very quickly. So, ideally, if you could acidulate, as soon as it's picked, that would be ideal. I know the logistics of that may be insurmountable, but it's something to consider. With white wines, what I like to do and what I've done in the past is try to mimic the final acid profile. So, it's usually about 2/3 tartaric and 1/3 malic, and then there's a tiny bit of citric with white wines. So I like to use that blend to make adjustments. With reds, they're most likely going to go through malolactic, so using just straight tartaric is a good method. There are plenty of calculators online that will help you determine how much acid you actually need in order to get your pH shift. I think acidulation is probably one of the most complicated and difficult to really dial in. Every juice and every wine is going to have a different buffering capacity. You can add a gram per liter, and not really see any shift, and then you hit your 2.5 grams per liter, and you'll see a very significant shift, and then some of it can drop out later. But the idea is just to try to get it lower than 3.6 as quickly as possible. Obviously, if you do add acid and you have an active fermentation with, let's say, an implanted strain that you've purchased on the commercial market, and they're actively fermenting, and then you make an acid adjustment, you're also going to stress those yeast out quite a bit too. So you have to be a little cognizant of when you acidulate. Some people have used citric in the past. I don't recommend using citric for a couple of reasons. From a sensory perspective, citric acid, that orange lemony flavor that can come from citric, isn't super desirable in a lot of wines. Also, citric acid can be a carbon source for spoilage organisms, particularly bacteria. So while you may be getting a pH shift, you're also giving some of the bacteria something that they can metabolize. So, and when they do that, they can produce some pretty nasty aromas and flavors. So I would recommend sticking with tartaric and malic for the most part. So one of the things I really try to harp on is this relationship between pH and SO2. Talking with winemakers, not only in Texas and the Midwest, but also on the West Coast, there's a lot of concern about using SO2 and utilizing it as prophylactic. So instead of looking at the pH and making adjustments based on that, a lot of people are just making prophylactic adds, like, oh yeah, I add 30 parts before I go to barrel, or I want to make sure it's 35 before I go to bottle. And while that may be a decent method, you really need to look at your pH. They're intrinsically linked, and the activity of the free SO2 is linked to pH. And you could go down a rabbit's hole. There's plenty of material online that explains this. But this table right here is a really good guide to look at what you need. I think most winemakers feel that 0.8 parts per million molecular is considered pretty effective against bacteria and yeast. Some people, will be in the 0.5 or somewhere in between. But the point here to take into account is, if you look at these pHs, if you're at 3.7, which is very reasonable and common, especially in Texas, even up into the 4. In order to get 0.8 molecular, you're already at about 60 parts. One thing I want to warn against is, if you're at 3.8 or 3.7 and you want to get 0.8 molecular, the sensory perception threshold is about 60 parts per million. So if you're in this range of free SO2, you can really smell it, and it'll be really dominant in the sensory profile. So you kind of have to take that into account when you're making your SO2 ads. There are other adjuncts, additives, and things you can use to make your SO2 ads more effective, and we'll talk about some of those here in a minute. One thing I want to point out is, there's a lot of, I think, myths and misconceptions and belief systems out there about red wines in particular, but maybe more specifically SO2. There's a lot of people who say they're allergic to SO2. I'm in the camp that doesn't believe that you are. There is some sensitivity, of course, right? If you've ever opened a bag of KMBS or made a liquid solution, yeah, I mean, it can be a little bit agitating to your nose and your respiratory system. But an actual allergic reaction that people are referring to, I think, is due to something else that we'll get into here in a second. So it's been used since Roman times. It's present in almost all fermented foods. It is a natural byproduct of fermentation. And, when's the last time you heard of somebody being allergic to a salad bar? Because they use a lot of sulfur there to keep things from browning. Also, dried fruits have a lot. There's quite a few foods that have a lot of sulfur, and people aren't typically allergic to that. But they do say it's very common. Again, this is a generalization that they're allergic to red wines and the sulfites. The problem with that is that typically white wines would have higher levels of SO2, just very generally speaking. The biggest difference, in my opinion, is that red wines typically undergo a malolactic, and given where I'm at in the industry, on my side of things, I can look at what people are purchasing and kind of do an analysis and look how many people, what quantity of yeast they're buying compared to how much bacteria they're buying. And there's a lot of people undergoing native or what I consider spoilage malolactic. And by using a native strain that's in your winery or coming in from your grapes, or maybe is present in your barrels, the barrels that you may have purchased secondhand from a winery on the West Coast, and you're relying on those bacteria strains to do your malolactic, there is a super high chance of producing biogenic amines. And if you look here, the most common one is histamine. We all know, if you have an allergic reaction, you take something like Benadryl, which is an antihistamine. So, in my opinion, I think the allergic response that people have to red wines is more due to this than it is any sort of SO2 reaction. Some of the other ones, tyramine, cadaverine, and putrescine, and yes, those last two smell as bad as they sound. But let's get into that a little bit more. So, high pHs favor the production of these biogenic amines. There's a distribution of histamine here on the left, and at the various pHs, you can see at these higher pHs that we're dealing with in Texas on our red wines, there's a very high propensity for these to be produced. So things that make you go, are people allergic to SO2, or are they allergic to bad winemaking? And I'm being facetious there. So what depletes SO2 and what compromises its effectiveness? So if you have a bag of granular KMBS that's unsealed and it's been sitting out, and you make an SO2 ad and you don't see the shift that you want, one of the things that could have happened is it could have absorbed a lot of moisture, and it will deplete the effectiveness of the SO2. So where 100 grams would typically get you, let's say, a 10 part per million shift, it may only get you a 2 to 5. So that's something to keep in mind, and I'll talk about a strategy to protect your additives downstream in this presentation. The other one is oxygen. So if you know anything about me, you can probably say the one thing that I'm super militant about is controlling your oxygen and your dissolved oxygen. I think along with pH, VA, alcohol, and sugar measurement, I think it is one of the most important things that you need to be able to measure in your winery. I'm not going to get into this too much. I've done plenty of presentations on this. There's plenty of material out there. If you want it, I can talk with you later about it. But Most people have way too much dissolved oxygen, and this binds with SO2, or I should say one of the radicals, but essentially 1 part per million of dissolved oxygen binds with 4 parts per million of SO2, free SO2. So when you're doing splash racks transfers, different cellar actions, you actually pick up a lot of oxygen. This is exacerbated the smaller your winery is. So this is one of the reasons why the very large wineries across the world, they don't have as much or as many issues with oxidation and free SO2 depletion, because their batch sizes are so large. Whereas the smaller wineries, they have to be much more careful. So one of the things that I recommend for people to do is, you typically know what your SO2 level is in your bottling tank. I recommend for them to measure their free SO2, like go grab a bottle out of the warehouse and measure it and see how much is depleted. That is indicative of how much oxygen you picked up during bottling, AKA bottle shock. I also have taken it upon myself to try to introduce the term barrel shock, because I think the same thing happens, just on a little different scale. The other thing that can deplete SO2 is microbial growth. So when you see really big depletions of free SO2, it could either be an oxidation issue, or you could have some sort of microbial growth taking place. This is an expensive DO meter. It's also a pH meter, but it's a very good one. There are other ones available on the market, and if you want to discuss which one to look at and that sort of thing, we can have a discussion afterwards. But your SO2 levels with proper handling of the wine should remain relatively stable. If you do see a significant drop after a movement, you probably have way too much oxygen exposure. This is exacerbated by using certain types of pumps, not gassing your lines and your receiving vessels with some sort of inert gas. This is one of the reasons why a lot of winemakers that are trying to be very gentle with their wine, they advocate gravity filling as opposed to pumping, because they believe that the pump damages the wine, and they often relate it to the speed in which an impeller spins and it shearing the wine. In my opinion, it's less that and more so the oxygen that the wine gets exposed to during this. So I think a lot of winemakers would generally agree that if they have a Brettanomyces infection, or maybe some sort of lacto or a bacterial problem, it's typically in the barrels where this occurs. And there's a few reasons for that, and we'll get into those. So why do we have all the spoilage happening in the barrel? So this is kind of a delicate topic, because this is challenging some very common methodology out there. The reason it's common, I believe, is, well, it's just what we've always done. And I question whether or not we should be doing what we've always done just because we've always done it. There's the whole hawk off the ham analogy that can be done here. So people will top on a regular basis to prevent oxidation. Well, if you've ever opened the bung of a barrel, you can probably remember in your mind's eye or your mind's ear what that sounds like. It's a whooshing of air into the barrel, because once you fill the barrel and you put a bung on it, the wine will soak into the stave, and there's a vacuum that's developed in the barrel, and it keeps that bung pretty tightly secured. And so I question, how much oxygen is actually in a vacuum. So we continually top on a regular basis, and a lot of people don't have a DO meter, and they're not measuring this, and so they're topping and topping and topping to prevent oxidation. In my opinion, I think they're actually oxidizing their wine. So I think some critical thought on what you're doing and doing some measurements is a good thing to start looking at. If you go to barrel at, let's say, 50 parts per million free SO2, this is regardless of pH. Say you go to barrel at 50 parts, but you have, let's say, saturation of the wine. Let's say it's about 8 parts per million of DO. Plus, you're not inerting the barrel, so you're going to be exposing the wine to all that air inside the barrel. If 1 part per million of DO binds up with 4 parts per million of free SO2, and let's say you have 8 times 4 is 32. So you've almost completely depleted your free SO2 that you want to barrel with. And so I think this is one of the reasons why we have a lot of problems with spoilage in the barrel. I think it's just one of those things that you need to think of as a winemaker on why you're doing what you're doing and what your goals are, and whether or not, and measuring whether or not you're achieving those goals. So generally speaking, what I would do, or what I would recommend a lot of people to do, especially with the high pH reds, before you barrel down, like you've got your wines, been through primary, been through mallow, you cleaned it up a little bit. Now you're going to go to barrel. I would recommend sparging with nitrogen and getting the DO out of the wine, getting the dissolved oxygen down to a low level, and then gassing your barrels with some sort of an inert gas prior to filling. And this will help with your pickup and thereby increase the persistence of your free SO2. So I usually get ahead of myself here, but here's kind of an instruction on how to do that. A lot of winemakers do when they top. The topping wine is usually really high in SO2 to try to combat some of this. So one of the things I like to look at in general concepts to try to communicate is the solubility of any gas is inversely proportional to temperature. So the colder you are, the more gas you can dissolve. The warmer you are, the less. So, I think we all could kind of identify with this when it comes to, like, let's say a 2-liter bottle of soda or a half-empty bottle of champagne. If you leave it on the counter, that CO2 is going to come out of solution fairly rapidly, whereas if you put it back in the fridge and hold it, it's going to persist much better. So the same goes for oxygen. So temperature is a really important thing, and I'll show you some more about that in the next slide. So your different cellar operations that you can do, you can see a table there on the left that shows the range that you can get. So if you consider saturation is 9 parts per million, give or take, it doesn't take too many of these movements to be at full saturation and continual saturation. You'll notice cold stabilization is one of the highest. That's because of the low temperatures that you do cold stabilization at. Also racking with O2. I'm a huge opponent of splash racking for a number of reasons. So if you look at the temperature of what you're doing things at, so if you're at 70 degrees, which is a little warm, I think, for most cellars, your average pickup for a wine transfer is about a half a part. At 50 degrees, which I think is closer to where a lot of people are at, it's almost 3 times that. Also, if you're looking at cold stability temperatures, your oxygen solubility is up 14 or 15. And if you've ever tuned into one of my other webinars, you're probably rolling your eyes because I hammer on this on a regular basis, but I think it is really super important, especially for high pHs, especially for smaller batch wine making. It's really something that we need to be aware of. A lot of the issues that I see in commercial wines out on the market are directly related to this, because it's not just that oxygen in itself is bad, it's that there can be some chemical oxidation, but that dissolved oxygen can feed things like Acetobacter and Candida. Candida makes the floor yeasts that create the mycoderma on the top of the wine with the tank that has some headspace. I'll show you some pictures of that. So I think a lot of this, it's not the primary reason. It doesn't cause, let's say, something like mousy taint, but it can deplete the SO2 and allow the microorganisms that cause mousy taint to go ahead and proliferate. So it's not the primary reason, but it's maybe the secondary reason. So real quick, I'm gonna blow through this because I've belabored this before in the past, but using a stone setup like this and high purity nitrogen, you can remove almost all of the dissolved oxygen, which will make your SO2 adds much more effective. So if you're looking to use less SO2 for some sort of like philosophical reason, this is a really good tool to have in your arsenal. Another way to control microbial populations or to ensure a relative amount of stability in your wine is to create something that's generically termed as a nutrient desert. So ideally, let's say in a red wine, you might use some sort of fermentation nutrient like Fermate O or Fermate K or DAP, something like that. The ideal thing is you're doing that based on knowing the endogenous or the native nitrogen that's there in the grapes. And then you're adding enough nitrogen in order for the microorganisms that you want to be active to do their job, and that's it. You don't want to add it prophylactically without knowing, because you can add so much that it persists after your preferred fermentations and is present to feed spoilage microorganisms. Grapes really are, I think, in my opinion, the most preferential fruit on the face of the planet to make alcohol from. The sugars are there, the acids are there, the nitrogen a lot of times is sufficient for an adequate fermentation, and whereas other fruits like cherries and apples and other things that people might make wine from, you usually have to do quite a bit of supplementation in order to get the fermentation to finish. And the YAN or yeast assimilable nitrogen needed for a healthy primary fermentation is based on quite a few different factors, but generally speaking, the potential alcohol. So your final alcohol number. An easy fermentation would be something around 10 bricks, and you need about 100 parts per million of nitrogen in order to do that. I think in Texas with red wines and in California as well, and some of the hotter climates, you're talking 14, 15 percent alcohol. So you need quite a bit more nitrogen in order to do that. And every yeast strain is going to have a different uptake and usage of nitrogen. So it's kind of a lot to consider when you're looking at making a nutrient add, but ideally you're measuring your YAN and making a supplemental add based on that to a specific target level. If you, again, to reiterate, if you have leftover nitrogen that the selected yeast and bacterial strain that you have used to do your primary and secondary fermentation, if it's left over, then it can be used by other spoilage organisms. Additionally, you want to try to eliminate the carbon sources. So this gets into wine style. If you have a dry malolactic positive wine, there's a lot fewer carbon sources that spoilage organisms can use compared to something that like a Beaujolais Nouveau that hasn't been through ML and still has a little bit of residual sugar. That's has a much higher risk associated with it for it to go through some sort of spoilage. Examples of carbon sources would be fermentable sugar. So even if on your hydrometer or your densiometer it is quote unquote dry, there still can be plenty of fermentable sugar in there for spoilage organisms to chew on. Also, malic and citric acid can be used as carbon sources for some bacteria. So not only do you want to try to create a nutrient desert by making targeted nitrogen adds, but also when you're moving things around in the cellar and you're prioritizing in a hierarchical way which wines are more risk prone than others, looking at the carbon status of the wine is important. So again, dry malolactic positive wines are less likely to degrade compared to those that have not been through malolactic and do have some residual sugar. So here's a picture from Texas. This is the flash detente system at Bending Branch. These are becoming more and more prevalent. It kind of started, I would say, about 10 years ago on the West Coast. They'd been used in Europe for a period of time, but it sometimes takes a while for things to get adopted over here. But very generally with temperature, lower temperatures equal less activity. But if you remember back to the previous slide where oxygen is more soluble at those lower temperatures, while you might have less growth of, so let's say, a spoilage population, you could have a downstream risk from the oxygen that does get dissolved once you warm the wine back up. One thing I think is really important, this is kind of a side note, I think in America we try to be very specific about things. Like we want 100% Cabernet from a specific vineyard on a west-facing slope on a certain clone, and it's very specific. There's nothing wrong with that, but I think we use that same mentality a lot of times when it comes to our microbial populations and how we perceive those things. For example, a winemaker might say, "Oh, I've got some Brett in that barrel," and a little voice comes on in the back of my head, and I'm like, if you have Brett in that barrel, you more than likely also have Pediococcus and some other populations. There's been some really good research that's come out of Oregon State, I believe, that shows there's an interplay between Pediococcus and Pediococcus and Brettanomyces, where Pediococcus will actually do one of the intermediary steps for Brettanomyces and one of the metabolic steps to make Brett its job even easier. So where you typically have the population of Brett, you should also have the population of Pediococcus. So I think that's just important to think about. It's not just usually one microorganism that you have in your wine. It could be a number of them, and they occur at the same time. Another thing to consider, this is a quote from Denise Gardner. I was listening to one of her webinars a while back, and I thought this was a really good illustrative statement that acetic acid bacteria spoilage occurs twice as fast with every 5 degrees Celsius increase in temperature. So you can see the difference between, I work in Fahrenheit most of the time. So 50 degrees, 60 degrees, 70 degrees Fahrenheit, you can really have some vast differences in microbial growth at those temperatures. The reason I put the flash system in as just to have a picture, but also, thermovinification has been around a long time. This is essentially a pasteurization step that you do on the fruit or on the grapes or on the juice. Flash détente is a derivative of that. There's a few extra steps in there, but you're basically pasteurizing stuff. So whatever microorganisms are coming in from the vineyard, or maybe that have grown, proliferated in the, during shipment, you're knocking that population down significantly. So, if you don't have a flash détente system, but maybe you have a heat exchanger, you can do some thermovinification. And this is really handy on stuff that has rot, for example. If you have damaged fruit, if you're using a mechanical harvester that's very rough on the fruit, and this is sometimes due to the type of mechanical harvester, but also the ripeness of the fruit. It could also be who's operating the machine itself. If you do get a lot of breakage and you have a long, hot, high pH grape hull, you can have some growth really fast. And so you may want to think about, in those situations where you get the fruit and you're already smelling some VA, maybe some ethyl acetate and some of that nail polish remover stuff, you may want to think about thermovinifying it or doing a slight pasteurization. And that'll help knock down those populations, and that will enable an implanted strain to get a good foothold. I understand the motivation of doing natural winemaking and indigenous strains and all that sort of thing. In the case of damaged fruit or high pH wines, I think you have to be very careful on implementing those sort of strategies. If you had beautiful fruit that was, intact and whole and clean and didn't have any damage, and its pH was nice and low, by all means, assume the risk and try some native strains. Just know that if you don't have good, intact, clean, low pH fruit, your risk of spoilage and bacterial growth is much higher. So I think those are things to keep in mind. And most of the time, if you've ever used the commercial strain in your winery, of yeast, let's say D254 or EC1118 or something like that, a strong strain, that natural fermentation that progresses is probably D254 or EC1118. So there's a little bit of misconceptions there, I think, and but I don't want to dive down into that too much. If you do have some spoilage, there are things that you can use. This is primarily after fermentation, but there are some newer finding aids that are on the market nowadays that weren't around 10 years ago, and they're ketosand type glucan products, which are derived from aspergillus. They're non-allergenic. They're not animal-based, and they will, if you add them, they will actually kind of agglomerate around the spoilage organism. They precipitate it, so they settle out, and then during that process, over a period of a few days, they actually have a physical action on the cell wall that cuts the cell wall and basically kills the cell. You do have to rack off. You don't want to just add this and leave it, because over a period of time, as you cut those cell wall opens, they're releasing their intracellular contents, and some of these intracellular contents are basically food for other organisms. So if you leave it on the lees for too long, you can have some of this rupturing take place, and then you can have a subsequent bloom of maybe another spoilage organism. There are a lot of different formulations of this stuff on the market. ScottLabs has Spactolus, which is really nice because it's both active against gram-positive and gram-negative bacteria. So this is not only Acetobacter, but also Lacto and Pediococcus. And then the Nobretin obviously is active against Brettanomyces. So you can also use common finding aids, something like a gelatin or an isinglass or a hot mix sparkaloid, a silica gel, and I'll talk about it a little bit more in the next slide. But you're essentially trying to clarify the tank and get all those organisms, whether it's yeast or bacteria, whatever, settled to the bottom of the tank, and then you either rack or you filter off. And this is kind of a pictorial way to look at it. You have organisms all up and down throughout the tank. You add your finding agent, they will precipitate down to the bottom of the tank, and then you rack this clarified stuff off. So, takeaways or maybe things that you can use in the cellar to diagnose issues, or maybe even diagnose problems in the bottle. I always carry a flashlight with me. So if I have a wine that's in the bottle and it's got some problems with it, and I'm trying to figure out what's going on, if it's turbid, if it's murky, if it's not clear, that's usually a pretty prime indication that there's been some sort of microbial bloom. So generally speaking, the more clarified the wine is, the less microbial activity is taking place. And this is another representation of it. This is kind of a pictorial representation on the right-hand side there of a lees filtration. So after you've racked the majority of your wine off the lees, this would be taking something that's really, really high in solids and clarifying it with either a rotary drum vacuum filter or a DE pressure leaf filter, something, maybe even a crossflow, high solids crossflow, and you can recapture the wine that's in that lees. A lot of people just dump their lees. Depending on your bottle price, it could justify the purchase of some equipment to do this. But examples of filtration, I'll show you some pictures here in the next slide. These are not interchangeable necessarily. There is some crossover, but there are some eccentricities between each one of these things. And this is not a filtration topic or a discussion per se, but I'll get into a little bit of this. You have diatomaceous earth pressure leaf filters, where you add diatomaceous earth into the wine and you build a filter matrix of DE onto a stainless steel screen and pass the wine through it, and the solids are left behind. They're fairly inexpensive as filters. They're pretty difficult to run, so you need a skilled operator. They're kind of falling out of favor in the wine industry, but they still do have some usage. Plate and frame filters, I think those are very common for people. lenticular depth filter. So a lenticular and a plate and frame is essentially the same exact filter media, just packaged in a different way. Then you have cross flows, and I could do a whole presentation just on cross flows, a lot of different kinds, a lot of different membrane materials, a lot of different control parameters. But usually for a smaller producer, cross flows are out of their price range. Then you also have membrane filtration, and membrane filtration is really only to be used right before bottling. They have very little dirt holding capacity. They are not going to be able to filter lees or very much solids at all. So if the wine isn't almost brilliantly clear to begin with, you're probably going to plug your membranes. And then a centrifuge is another example of a clarification device. It's not necessarily a filter, but here's some pictures of, this is the plate and frame right here. This is a lenticular filter. This is a cartridge filter setup. I highly recommend having this sort of arrangement where you have a pre-filter and a final filter. And then also you want the valves and tees and pressure gauges necessary to be able to isolate either one of these. The idea here is this is going to be your absolute final membrane. It's 0.45. It's integrity testable. It's a sterile membrane. You'll hear people say, oh yeah, I EK filtered it, or 0.45 filter, and that's sterile in a plate and frame. That is not the case. You cannot get sterile with these two. The only way you can do it is with a membrane filter, because you can test the membrane. You can't test the integrity of these things. But back to this, you have your 0.45 absolute here, and you want a pre-filter in this tube that catches the last remaining solids, if there are any, so that you plug your pre-filter as opposed to your final filter. By plugging the pre-filter, if that's the case, hopefully you don't, but if you do, they're much less expensive, and you also don't compromise your sterility by swapping this out. So if you plug this, you close some of these valves, you flush the wine out, break down the system, put a new filter in, wet it down, and then you're off and running to the races, and you haven't compromised sterility. So that's the reason behind this sort of setup. Here's a pressure relief filter right here. This is actually one that I sold to a brewery a few years back and was showing them how to run. That's a fairly large filter. Most wineries don't need something that big. That's about a 10 meter. This is a centrifuge. This is at a brewery. This is a picture I took. You can actually see a lot of the solids right down here on the bottom. These things are fairly easy to run. The problem with centrifuges and crossflow filters is they're fairly expensive. This is easily 6 figures, as are most crossflows, and that's what this is right here. So it's different tools for different situations. And if you ever want to talk about that, you can talk to myself or Maria Peterson. She's our resident filtration guru. So real quick, I'm going to blow through these, but just to give you an idea and some visual representations, this is a depth filter. So this will be like plate and frame or lenticular, or even a DE pressure relief filter. You're basically passing the fluid directly on some sort of filter media or a DE filter bed. The particles get trapped in the labyrinth or the matrix that it is the filter media, and then the clear stuff comes through. Another picture of this, you can see you have the dirty stuff on this side, your pathway is through here, and most of the solids and particulate get caught in here, and then your cleaner wine comes out the other side. The goal here is removing solids. While you remove solids, you are also trapping microorganisms. So this is what we refer to as dirt holding capacity. One of the nice things about DE, now some filter pads and some lenticular media actually do have DE inside of them. Diatomaceous earth does have a charge associated with it and can actually capture and attract a lot more microbial cells than something without DE. So kind of a interesting little thing. If you want to learn more about that, we can chat later. But membrane filters, again, this is those cartridge filters, long skinny ones. They really have a high precision and accuracy, very low dirt holding capacity. These are just your very, very last stage of filtration going to bottle. Crossflow, PES, PVDF, glass matrix. There's a lot of different types of membranes out there. Here's another picture. This is what Enococcus oeni looks like. This is malolactic bacteria. That's what they look like on a membrane surface. not going to get into this too much, but I think there's two concepts to really be cognizant of here when you're talking about shelf stability, sterility, and eliminating populations of yeast and bacteria that could cause you problems downstream in the bottle. Nominal and absolute. They're two different terminologies and they're not interchangeable. Nominal means that most of the pores and the pathways are a particular size, and they will retain a particular size organism or solids. Absolute means that every single one of those pores is exactly the same size, and you can test that. So examples of nominal would be crossflow or plate and frame or lenticular. Absolute is going to be that membrane filter, that last filter that you use to filter on the bottom line. So nominal versus absolute is important. The other important thing when you're talking about cartridge filters and specifically membrane filters is tighter reduction values. And this is where, you know, if you order a filter cartridge from ScottLabs, it's a 30-inch cartridge, it's about $300. And there may be a competitor that has one for $150 and they say it's the same thing. You need to look at the tighter reduction values. And if you look right here, this is looking at different retention of a known microorganism. So 10 to the 6th versus 10 to the 9th reduction. We'll look at that right here. So like on a site's 10 to the 9 reduction of a known microorganism versus a different brand at 10 to the 6th. You know, this is still a lot of 9s, right? It's 4 9s, and then this is 7 9s. What does that mean? Well, with 10 to the 9th, you're talking potentially if you have 1,000 or 100,000 cells per mil, that means that you're going to potentially have 0.075 bugs per bottle. Okay, so there might be, you know, 0.07 yeast cells in that can make it through. If you're 10 to the 6th, now you're talking 75 cells per bottle. Now, taking that into context with your pH and your SO2 and your dissolved oxygen and your tannin load and your alcohol levels, you know, is that going to make a difference? Maybe, maybe not. I would suggest, you know, if your wine has residual sugar and maybe hasn't been through malolactic, then 75 cells is absolutely enough to cause you some problems because they will grow. You know, I get the question a lot of times, like, well, how many cells in a bottle or how many cells does it take to re-ferment a wine or to cause a problem? And the answer is 1. So I think that does, you know, not all things are created equal. Just generally speaking, some filtration terminology, you have rough, polish, and sterile or sanitizing. And so you're talking with rough, it's greater than 5 micron. This is your K700s, K900s, maybe a DE filtration. Polish filter, this is when you really start getting that final clarity and brightness where the wine sparkles. And then this below 1 micron is where you actually start pulling out microorganisms. So tools, you know, to use in Texas, for example, with those long grape hulls. There's been a prevalence of a lot of people in the industry to want to try cold soak. And through that, over the past few years, you know, there's a lot of problems that are associated with cold soak, or that can be. But there are some positive microorganisms that you can buy and implant that are not fermentative. They just grow. They consume a few bits of nitrogen, but what they do is they actually secrete toxic compounds that are toxic to other microorganisms. They're not toxic to humans, but they inhibit other microorganisms. One that we have is called Gaia. It's Metricovia fruticola. You still would need to follow this with some sort of Saccharomyces in order for the fermentation to progress, but you can use it in cold soaks, or for you know, Texas example is, you know, implanting it out in the vineyard, you know, sprinkling it on and then shipping the grapes, and it's a biological alternative to SO2. I think the important thing to tie in is looking back at that pH and SO2 chart. You know, if you're at 4.1 on a Tempranillo or upper 3s, and you add, you know, 40 parts per million SO2 in the bin, you're really not getting much antimicrobial protection there. And so at those higher pHs and those temperatures, you know, I think this is a very good tool to use, that lowers the amount of SO2 to use, and also is probably more effective than SO2. For example, it has been used in some countries to hold mûté. Mûté is an old French technique that you receive the grapes, you press them off, you get the juice, and then you're holding that juice through harvest to use as a back sweetener. It's fairly difficult and requires a lot of expertise and skill, but you can use this the Gaia to prevent re-fermentation in that juice. So that's what mûté is. Kind of another way to look at it, this is allelopathy, which is some plants have the ability to produce compounds out of their root zone. And you can notice here, there's not much growing in this where the root zone is. And this is allowing this plant to outcompete for water and nutrients and things like this. This is a visual representation of the principle that I'm referring to that Gaia will do. If you want some more information on how this works and the different pathways and the different compounds that these organisms can produce, I'd be happy to send you some papers and give you some information. But I think this is a really good representation of what's going on. If you are packaging wines for distribution, and sterility and shelf life has been a problem in the past, there are things like Velcorin. It's very effective against yeast. It's moderately effective against bacteria. ScottLabs sells it. We're the only ones who sell it. It does require a dosing machine. These are about $80,000, so it's not for everyone. There are some people who share it. There are some mobile services out there. I don't think there's one in Texas yet. I'd love to see one, but you can. One of the things where Velcorin really comes in is for wineries that start getting into products that are a little bit riskier to package. For example, if most of your production is high alcohol and it's dry and it's been through malolactic and you have a fairly low risk, that's not a problem. But if you start wanting to package, a slightly carbonated, non-malolactic, sweet, low alcohol Moscato, for example, it's a really, really high risk for re-fermentation, and that's where things like Velcorin come in. Or if you get into, say, something like cider. So it's different tools for different strategies and budgets and that sort of thing. If you're into distribution, you need to put out a shelf-stable product. So you either pasteurize the product, you either sterile filter it, you use Velcorin, perhaps you use sulfur and sorbate, or you rely on cold chain. This is what the breweries typically do, is they rely on cold chain distribution. The distribution network for wine assumes, generally speaking, that the wine is stable. However, a lot of wines out there are not. So we kind of have to do something else. So SO2 and sorbate. Both SO2 and sorbate are microbial inhibitors. They are not killers. I've heard it's just very common to hear, oh, I've added SO2 and sorbate and I killed all the yeast. No, you didn't. You just inhibited them. So, for example, with sorbate, it helps prevent yeast re-fermentation. It does have an efficacy period, and it will diminish over time, and that sorbate will inevitably degrade into ethyl sorbate, which smells like pineapples or celery, more celery than pineapple in my opinion. But while it inhibits yeast, it is actually a food source for some bacterial populations and can cause geranium taint. And it takes a very, very small amount of this byproduct to completely ruin the wine. The wine smells exactly like geraniums. You can smell it a mile away and the wine's burned. So all of these things come with their maybe their positives and then their negatives. The positives of sorbate and SO2, it's fairly easy to use, it's fairly cheap, but the negatives are it degrades over time, it can actually be food for bacteria, and it degrades into a sensorially active aroma that's not very pleasant. And it is not a replacement for SO2, it must be used in combination with SO2. Of course, when dealing with microbial populations, if your tanks and your equipment look like this, you have got things everywhere. You've got a problem. There shouldn't be fruit flies in the winery. It shouldn't smell in the winery. It should be clean. It's one of the ways that a lot of consultants will go into wineries and instantly know whether they have a sanitation problem or not is what the winery smells like. If it smells sour, if it smells bready, if it smells, kind of like some putridness, you have a sanitation problem. This is a biofilm right there. You have to physically remove that stuff before you can add any sort of sanitizing agent. So this would require elbow grease, or if you have a tank washer or a barrel cleaner, you got to remove this soil and deposits before you can actually use any sort of sanitizer. Once you remove the soil, you can use things like ozone, maybe UV light, perhaps something like Destainex or a percarbonate, some sort of oxidizing agent, which is essentially what ozone is. That's the same thing with the OxyClean or percarbonate or Destainex. They're all oxidizers. Bleach is an oxidizer. I would highly recommend not using bleach in a winery, but people do. But it's all just an oxidizer. Okay, so tips and tricks. So practical applications for the cellar. So I like to show this picture. On the left, you have what I consider improper hose storage. And on the right, you have, I think, one of the best hose storage systems that I've seen out there. This is actually at a Texas winery. But on the left here, these hoses are coiled. And what happens is wine, water, diluted water will end up hanging out right here. And you'll have a lot of microbial growth right there. So you want to make sure that, what I've also seen is you have hoses that people will drape like across 4 of these little hose hangers, and they're still draped and there's a low spot in between each one of them. You really want to try to avoid that. Something like this, there is no place for the microbes to hang out and pool and fester. So this is a really good system. This should be obvious, but you want things dry and clean, and this is a pretty good little bucket stand. I've seen PVC bucket trees. You want things to dry, like with your ball valves, for example, when not in use, they should be open to about a 45-degree angle to allow the internal surface of the ball valve to dry out. Same thing with the hoses, have them completely drained, angled so that things dry and can drain. Hose care. Okay, this is a good little video I'll share. This is a friend of mine in the neighboring state here. But this is showing how to use a hose ball and also have fun at the same time. So I'll play it one more time. So basically what's happening here is there's a hose ball, see if I can catch it mid-flight, and it actually comes out the end of the hose. So what they're doing is they're running a sanitizer solution, cleaning solution through their hoses, and then they'll break the line on the outlet of the pump and jam that hose ball, sponge ball inside of the hose and then circulate it. And they're having a little fun seeing how far they can launch it. But this is actually a way to physically scrub the inside of the hoses. I highly recommend these. They're very inexpensive. They're easy to use. And the first time you use them, you'll notice that the water will come out just black out of the hose if you've never used them before. So this is really good for hose care. The other thing I recommend is replace hose ends before and after every harvest. So this is an area that is very common for spoilage. It's that inner zone between the hose barrel and the internal hose surface. Under pressure, juice and wine will get kind of lodged in there, and you can see it a lot of times. If you're using 2 different clamps, in between the first and second clamp, there'll be some wine that will get in there. Well, that's just festering in there, and that's a huge spoilage area. So from a contamination standpoint, before and after harvest, I would recommend chopping those hose barrels off, cleaning them, and reattaching them. Also, the other thing that this helps is if you've ever noticed where a hose typically fails, it's right after the hose barrel where the hose is commonly bent. And this is just a physical fracture that occurs. So by doing this on a regular basis and replacing the hose barrels and shortening the hose by about a foot, you help prevent leaks in your hoses. You also want to use proper hose banding tools and techniques, and you want to stagger the tensioner, meaning if you have 2 or 3 clamps, and these should be like punch lock band clamps. The hose clamps that you can go buy your auto parts store or Home Depot are not proper hose bands. So they're specific for sanitary hoses. They're not that expensive, but what I mean by stagger is there is the tensioner that you actually you punch it with a punch lock banding tool, and that's what keeps tensions the band and keeps it in place. You want to stagger those so that they're not in the same position, so that you're kind of spreading the force out on the ferrule. It's easier to show in person. It's not that complicated, but you want to stagger the tensioner on the hose bands, and that makes a better seal. And use hose cleaning balls and proper cleaning agents, and you can have as much fun as this guy is having right here. Pumps. I think this is one of the most common areas of spoilage in the wine industry. I'm only going to talk about Waukesha's. There are plenty of other different kinds of pumps out there. They have like flexible impeller or air diaphragm pumps. Those are probably 2 of the most common. They're also 2 of the most commonly contamination sources. So you really have to take those apart, clean them, sanitize them. But I see a lot of Waukesha's out in the market. I'm a fan of Waukesha's. I like them, but there's 2 different kinds. There's what they call a U1, which is this one right here, and then a U2. There's only one company that I'm aware of that does this one. The U1 is probably the most common, and it's typically a burgundy colored pump. That you can notice a difference in the head design here, but this right here is a sanitary pump. This is non-sanitary, even though they'll call it a sanitary pump. It was pulled from the dairy industry. And what happens is you'll notice these have 2 rotor jam nuts here, and in order to replace the rotors, you take those off and you slide the rotor out. Whereas this has a cap nut and it's O-ring sealed. What happens in practical usage for these, they're meant in the dairy industry to be taken apart and cleaned before and after every single run. Wineries don't hardly ever do that though. And so they'll use the same pump to pump grapes, then to, pump the fermented, fermented fruit back to the press, and then they'll use it to barrel down, and then they use it for bottling. And what happens is wine and juice and whatnot will force its way behind those nuts right there into this rotor space and in between the rotor and the shaft. And if you ever take them apart, the first time you do, it's usually just growing with bacteria, and it's slimy and it's nasty. And this is probably one of the most common areas of spoilage in the wine industry. So if you have one of these pumps, they're great. They work fine, but you just have to know the idiosyncrasies about sanitation, especially for these guys. So do you have this? Have you ever seen this? This is a floor yeast. This is on the top of the wine. It kind of creates this this slime on the top of the wine. It's called a mycoderma. It's done by an oxidative yeast called Candida. And it's one of the only microorganisms that really forms, like something you can see. It's like a gel on top of the wine. If you have this is the wine screaming at you that you have improper headspace control. You probably don't have enough free SO2, and your dissolved oxygen in the wine is way too high. So you can remove this, but there should be some remedial actions. But if you have this, what I recommend is use this. Get a shop vac with a sanitized tip, and just literally just vacuum off this mycoderma off the top of the tank. And what you're doing by doing that is you're physically removing the population and probably logarithmically reducing it. After you do that, you need to adjust your free SO2, inert the headspace. You still need to do some remedial actions, but the first thing to do is get that population knocked down. So that's a pretty handy little trick. So if you do have some sort of microbial growth that is something you don't want, let's say a Brettanomyces or Acetobacter or Lacto, one of the first things to do, you need to identify what your problem is, because that's going to determine how you treat it downstream. So send it out for a microbial panel. You want to chill the wine as quickly as possible to limit further growth. That will also promote settling, so you can settle and rack. Ideally, you settle, rack, and filter, okay? And sparge the wine with nitrogen to drop the dissolved oxygen, and then add 0.8 part per million molecular SO2 based on your pH. Once you've done that, then you can send it back for a panel and look at what your population is at that point. If you still have a problem, you can go ahead and sterile filter to completely remove the microorganisms, and then rectify as necessary with things to cover up the problem or whatever you need to do there, tannins, that sort of thing. But when you do all of this, you do need to sanitize and sterilize all those fittings, hoses, pumps, the tanks, everything you used in the transfer operations, because essentially you're trying to contain an outbreak. So you don't want to do this and then take those hoses that are now infected with all of that bacteria or the Brett, and then go pump another clean wine around, because you're just spreading it. Okay, that should be common sense, but this is a good thing to take into account. Some more tips and tricks, little things that have, I think, a huge impact. So here are two different kinds of ball valves. This is a very, very common style ball valve. This is less common, although it is probably much better. What you'll notice here, the wine flows through here or through here. This has CIP ports. So when the valve is actually closed, you can open these up, drain the internal portion of the ball valve, and then you can actually pass through like either steam or some sort of chemical sanitizer or just hot water. So you're actually able to clean this. Whereas this one, you really can't. You have to take this completely apart to clean it. I still recommend disassembling and physically cleaning your valves on a regular basis. Also, if you have partial bags of corks or fermentation nutrients or yeast or anything like that, once you're done using them and you're ready to put them in storage, go buy a vacuum sealing bag and remove all that oxygen and the humidity out of there and vacuum seal it. And that really helps prevent not only moisture degradation and mold growth on things, but also protects them from contamination. And that's about all I have. Resources, you got me. There's also the technical staff inside of ScottLabs. So Maria's our filtration specialist, and then there's a number of other people that you can talk to about some of the more technical topics when it comes to microbial populations. So that's about all I have.
Thank you, Luke. We have some questions. I'm going to read them out. You may be able to see them on your end as well, but I'm going to read them out. What products do you recommend using for cleaning mechanical harvesters in the field, especially when you come across fruit that already has bacteria issues?
So in that case, it's kind of difficult to clean harvesters. I think, a lot of people use hot water or even just cold water, maybe a pressure washer, and that's good, that helps. But if you already know you have a problem, you kind of want to go to the next step. And in my opinion, the next step would be some sort of foaming oxidizer. So we have a product called D-Stainex, and it's percarbonate based, but it also has some other conditioners in there. And ideally, you want to get something that is foaming, so you can spray it on the harvester, on the beating arms, on the destemmer, on the sorter, and you're trying to get physical contact of the cleaning solution onto all the different entrapment zones. I look at some of the machines, not just harvesters, but destemmers and things like that, and the amount of moving parts in the entrapment zones are a whole lot of them, and there's a lot of places that are hard to get. If you can scrub them, even better. But kind of the old bachelor soak maneuver, right? You mix up something like D-Stainex or something that has some foaming action, spray it on there, let it soak, and then rinse it off with hot water. I would stay away from bleach for a number of reasons. So yeah, I would use some sort of oxidizer. You could use ozone. The problem with ozone is, it's going to be really hard on rubber and O-rings and any sort of plastics, that sort of thing. So, you're probably going to run into an issue there. I think the biggest thing with harvesters, and it goes for tanks or hoses or floors or whatever it is. if you've just finished harvesting or just finished draining a tank out, if you just use hot water within the first 10 minutes of draining that tank, you get nearly about, I would say 90% of everything rinsed off. That's the most important part. Once things are allowed to dry and deposits form, then you really have to, do some sort of physical action or some pretty heavy duty chemicals. So I would probably recommend some sort of oxidizing, scrubbing bubble effect is what I would look for there.
Thanks. Aside from cost, are there any downsides to using Bacillus as a preventative step?
Well, Bacillus is really primarily for remediation. If you want to put the wine through malolactic and you treat it with Bacillus, it's going to be it could inhibit malolactic fermentation. So that would be one of the negatives. You really don't want to use it on juice, as far as I know. And the other point is, if you do use it, you do want to rack it off within 7 to 10 days, so you prevent that autolysis from occurring in subsequent feeding of other spoilage microorganisms. But they're non-allergenic. They don't affect flavor. They're pretty effective. I mean, you get logarithmic reductions in activity. So I think, especially when you're talking about like a barrel that's got a problem, they work really, really well.
Cool. Next question, is nitrogen or argon recommended for gassing barrels pre-filling?
So I think the best gas for that would be argon. It is heavier than air. It is insoluble, and it's a really good gassing, inert gassing gas. CO2 can work. The only problem is if you have the entire barrel filled up with CO2 gas and you fill the wine, it can actually dissolve in the wine and cause maybe an exacerbated vacuum effect. So you have to be a little careful with that. Nitrogen works okay. I'd probably use nitrogen before I would use CO2. Only issue with nitrogen is lighter than air, so it doesn't really sink to the bottom of the barrel. But if you purge the barrel long enough with nitrogen, I think you're going to move the needle pretty well. But argon would be my first choice, nitrogen second, and then CO2.
Thank you. When creating a low oxygen environment in a wine after fermentation, what precautions or tips would you give to avoid reductive aroma?
So that's an interesting question, because that is very common out there, that people think that a reduced environment necessarily causes those sulfur compounds. That it causes a wine to smell reduced. Reductive or oxidative is simply a way to describe the redox potential of a wine. Those compounds that cause that reduction, they're there whether or not the wine's reductive or oxidative. What happens is it's a sensory perception. So what happens after fermentation's done, you'll notice the wine probably has a pretty good amount of oxygen in it, and that oxygen will eventually get consumed in photochemical reactions. And months after your fermentation is done, the wine, quote unquote, goes reductive. And so a common methodology is to splash rack. What happens is you are then oxidizing the wine. It's driving that H2S, the hydrogen sulfide, into a mercaptan and potentially into disulfide form by adding oxygen. And those compounds are less perceptible. They're heavier. You can't smell them. It requires a greater quantity, the greater concentration of them in order for you to smell them. So the problem, quote unquote, goes away when you splash rack, but it will eventually come back when the wine gets reduced again, i.e. when the wine is held in a reductive environment without a lot of oxygen. Where you commonly find this is post-bottling. Vast majority of wineries are fairly oxidative in their handling, and you'll package the wine will smell great in the bottling tank, and then it's bottled, and 6 months later it's held in a really tight environment and it gets reduced and you smell it, and then that's why you decant a red wine, for example, and you can you swirl the glass and it opening up, or it breathes, and that's what a lot of people think happens, is somehow the H2S, because it's fairly volatile compound, it magically flies out of solution when you splash rack or you agitate or something like that. It's really not what's going on. You're just morphing the H2S into mercaptans. So I'm a proponent of getting wines reductive, meaning very low dissolved oxygen immediately after fermentation. And if you have a problem that was produced during fermentation, you'll be able to smell it at that point, and you can treat it at that point, rather than keep adding oxygen and eventually have that problem show up in the bottle. So at least you can deal with it in the cellar. So that's a particular area of where I'm personally an opponent of a lot of the common methodology out there. So take that with a grain of salt. But you really shouldn't have wines get reductive in the bottle. You should be able to take care of them in the cellar. And as an aside, you also have much cleaner wines and much more stable wines that will retain their freshness and their fruitiness much longer in the bottle.
Thank you. What are the details of how SO2 reacts with oxygen? I read that they do not directly react with one another.
Correct. It reacts with one of, I believe it's a hydroxyl radical, but there's a lot of things that get into oxidation reactions. Your metal contents, the byproducts, the precursors, all that sort of thing. There's a lot of different tools to look at there. The oxygen does not bind specifically with SO2. The SO2 binds with one of the offshoots of an oxidation reaction. So, but it still will deplete the SO2. That's SO2's two primary functions are an antioxidant and an antimicrobial. So with what I'm talking about doing, if you remove the oxygen via sparging, that SO2 doesn't have to act as an antioxidant. It can persist as an antimicrobial.
Thank you. Would you recommend to drop the dissolved oxygen post-fermentation as quick as possible with nitrogen rather than naturally over time?
Generally speaking, I would do it immediately after primary fermentation. Like even before you go to barrel, and let's say you're doing malolactic in the barrel, your malolactic strains, they don't benefit from having oxygen. So but your other organisms that can be in the barrel that can cause spoilage, something like Acetobacter, they do like oxygen. Something like Brett, it produces way more VA in the presence of oxygen than in a reductive environment. So right after primary fermentation, before I even add SO2, let's say on a white wine, I lower it with nitrogen. Now, there are some wines, this is where it gets a little difficult. There are some wines that do benefit from, micro-ox in the barrel or micro-ox in the tank. And that gets into a wine's consumptive rate that you can measure by looking at volatile acidity, free SO2 depletion, and dissolved oxygen uptake. If you have a really good handle on those three things and you understand what consumptive rate is of wine, then by all means, maybe pick your strategy. The problem is that ETS, a lot of these laboratories, it's commonly known that oxidation is the #1 problem in wineries, commercial or otherwise, worldwide. And so I think we need to move the needle a lot more with being more reductive in our handling post-fermentation than I think a lot of people are right now. This is one of the reasons why the large wineries do use micro-ox, because they're not using barrels and their batch sizes are so big that they have a huge sink for dissolved oxygen. But if you're a smaller scale, and I mean that doesn't mean in carboys, that means in barrels, and even in 1,000-liter or 1,000-gallon tanks, your batch size is so small that you don't have much of a buffer, and you're probably much more oxidative than you should be. Now, this is where I'd say get a dometer and find out.
And finally, I have a question, more of a discussion than a question really. For Texas wines that have high pH and low malic acid to begin with. If the winemaker decides not to put the wine through malolactic fermentation, are there ways of ensuring microbiological stability in those wines?
On the fruit side or juice side or
Post-fermentation. So
where the finished wine-
post-fermentation, you have a red wine, you have high pH, you decide
Yep.
not to put it through malolactic. How do you microbiologically stabilize that?
So with the high pH, your SO2 is not going to be very effective. And if you choose not to acidulate, the levels needed to have antimicrobial activity are really high and probably at that point fairly off-putting from the sensory standpoint. So something like Bacillus, because at those higher pHs, it's really where the bacteria really likes to proliferate. And I've smelled a lot of high pH wines that clearly have bacterial problems. So using one of the Ketosan products, because the Ketosan products actually have somewhat of a residual effect that honestly we don't fully understand. But with no Brettanomycin and Bacillus, we found that once you add them to the wine, rack off, there's some sort of residual effect where the re-inoculation or recontamination is much less likely to occur. So I think those are probably two of the best strategies because they're not pH dependent necessarily like SO2 is. And then also, good sanitation and then getting the wines really clear. So filtering the wines, which I know is some sort of sometimes kind of like a philosophical thing. People don't want to filter their wines, but especially with high pH wines that may have some residual malic, they're probably higher alcohol. They could have a little bit of residual sugar in there. They're really ripe for things like Brettanomyces and some of the stronger lactobacterial. So, I would recommend filtration.
Thank you very much. And I think we're wrapping it up now. It's been an hour and 26 minutes, so a little bit longer than what our webinars go for. Look, thank you so very much for your time and presentation and all the information that you gave us today. Thank you everyone for attending. And I am very much looking forward to our next session. Thanks again, Luke.
All right. Thank you. Appreciate it.
Have a good day. Bye-bye,
You too.
everyone.